Hi guys, my name is Nick and I just graduated from Kuril 2020. So I joined coder school because I'm not sure where I'm going to take my career path in the future. But regardless of what I study, I know it has to be applicable to real life. So this leads me to my inspiration for my project. One day, I overheard my family speaking with my cousin who works for a small 4 people filming company. And despite the encouragement that he should leave for a bigger company, he refuses to. And his reasoning was that the day his company succeeds will be the testimony to his dedication and hard work. So for my final project, I decided to make a video that could increase the frames per second, also known as FPS of a video. So before I continue, is everyone here familiar with the term FPS? Great. And for those who are not sure what it means, basically a video is just a bunch of pictures put next to each other. FPS refers to the amount of pictures that are shown per second. The higher the FPS, the better the video looks. So my product would have great application for the post-production industry. To see why, please take a look at the chart on the board. Ladies and gentlemen, we have a problem. After a long day of hard work, we would all love to go back home, sit in our bed, watch a nice Netflix movie, or maybe hours of YouTube videos. But as our annual demand for streaming videos is rapidly increasing over the years, our suppliers, Netflix, YouTube, Hulu, their capability to provide us with this experience has fallen off. So in short, think about all the time you try to load a video and it takes ages to load. So to which I propose 2 solutions. The first is to reduce the resolution of the streamed in videos, and the second is to reduce the FPS of the streamed in videos. So as part of the subscription to these companies, they would provide you with software that could increase the resolution or FPS of the videos are being watched by the users back to its original quality. So let's take a look at what this would look like in reality. So for demo, I have prepared you guys with 2 videos. On the left will be a video at 5 frames per second, and on the right it has been predicted to 60 frames. And for demo purposes, I've also slowed the playback time to 0.5 so you guys can see the difference. So yeah, can you guys spot the difference? On the left, the video is more choppy and unpleasant to look at, and compared to the one on the right, where it's more smooth. So the cool thing about my model is that it also works on real life people. So here it's also a video of 5 FPS, which has been predicted to 60 FPS of the movie Black Swan. So yeah, can you spot how choppy the video on the left looks? So let's dive a bit deeper into my model. The model I implemented is called the Super Slow-Mo model by Google NVIDIA. To train this model, I used a 240 FPS video dataset consisting of 118 clips and a total of 80,000 frames. So first, I extracted out all the frames using OpenCV, and then I grouped into groups of 12 sequential frames. And for every group, I would pick out 3 random frames. And using the 2 outer frames of the time sequence, I would input that into my model, and the frame in the middle would be the targeted frame. So in order to synthesize an image, I will need to compute its optical flow. So what is the optical flow? Basically, every frame has unique pixel values, and since we're talking about a sequence of picture, the pixel values from frame 1 is related to the pixel value at frame 2. So the optical flow refers to the movement of these pixel values. So I need to compute the optical flow as it goes from frame 0 to frame 1, and as it goes from frame 1 back to frame 0. And using the 2 outputs, I could synthesize the new image. And to capture the optical flow, I use a special architecture called the U-Net Autoencoder. And this is a general pipeline. 2 images are passed through the first autoencoder. The optical flow is then captured, and then I can synthesize 2 intermediate images. I could stop here, but I would then pass my two new images into the second autoencoder, and the optical flow is further refined. And then the output is used to synthesize the image, as you can see in the bottom left. So to evaluate my model, I have two metrics, PSNR and SSIM. So PSNR refers to how well the pixels are being reconstructed, and SSIM refers to the similarity between the output picture and the targeted picture. So for the losses, I have 4 losses in total: reconstruction, perceptual, warping loss, and smoothness loss. And to end my presentation today, I would like to do a real-life demo. So here, I'm just gonna input a 10-second video at 10 FPS. And for every 2 frames, I would predict 2 extra frames in the middle. So now, as my model is predicting, I would like to revisit my original claim that reducing the FPS is better than reducing the resolution. So here's why. In order to up resolution one picture, it will take an average model around 1 to 2 minutes. But in my case here, I'm predicting 198 frames in total, and the amount it takes is less than a minute, as you can see here. So again, I'll just change the playback speed to 0.5 so you guys can see the difference. So yeah, again, can you guys spot the difference? The video on the left is the ground truth at 10 FPS, and the video on the right is the prediction at 20 FPS. So obviously, my model is not perfect yet, but with more time and resources, I could make a model that could predict even better quality photos or videos, and maybe even at a faster time. So to conclude my presentation, I'll leave you guys with a few statistics. With the assumptions that every Netflix users subscribe to the regular package, and on average they watch 2 hours per day, the amount of data that Netflix has streamed annually is 9 trillion gigabyte. But suppose if they were to use my model and only stream at 10 FPS videos, they would only have to stream 3 trillion gigabyte every year, and a difference of 6 trillion gigabyte of data could mean a whole change in revenue for Netflix. Thank you for listening to my presentation.